In this video, we'll learn about Storage Distributed Resource Scheduler, or Storage DRS. Storage DRS is based on Datastore clustering. So we've already learned a little bit about ESXi host clusters and how they can be used for things like high availability and DRS. A Datastore cluster is very similar. It's just a logical grouping of data stores. And these data stores may contain the files for many virtual machines. And as we add virtual machines, the data stores may potentially become unbalanced. So for example, maybe some really storage intensive workloads have been placed on data store 1. Or maybe data store 2 is running low on space. Storage DRS can automate load balancing across these data stores. And it uses storage vMotion. So just as a quick refresher, here we see an ESXi host with a virtual machine running on ESXi host 1. If I want to carry out a storage vMotion, what I'm doing is I'm taking all of the files that belong to that virtual machine and I'm migrating them from one data store to another with no downtime. That's what storage vMotion is. So the virtual machine continues to run on the same host, but all of the underlying files are being moved from one storage location to another. That's what storage vMotion is. And storage vMotion is the underlying technology behind storage DRS. So what storage DRS is going to do is it's going to automatically storage vMotion virtual machines around for the purposes of balancing both capacity usage and latency. So for example, if data store 1 is getting really full, or if data store 1 has a lot of storage intensive virtual machines that are generating a lot of traffic, it may start moving virtual machines to other data stores to even out that workload. Now there may be certain circumstances in which this can create some problems. Right? So for example, here we see two virtual machines, domain controller 1 and domain controller 2. And these are redundant. Right? We don't want both of our domain controllers to be down at any time, no matter what. But if we turn over control to storage DRS, it could potentially move those domain controllers to the same data store. And if that data store fails, we've now lost both of our domain controllers. So we can use something called an anti-affinity rule to ensure that those domain controllers are kept separated. We can even set up affinity or anti-affinity rules for individual virtual machines disks to keep them on separate data stores or to keep them together. But you probably don't have to do a whole lot of that. By default, if you create a virtual machine with multiple disks, all disks will be stored on the same data store. So one of the handy things about creating a data store cluster is you can put a data store into maintenance mode. So let's say the data store on the far left is on one storage device and the other two data stores are on other storage devices. And maybe I need to take down a storage device, like maybe a fiber channel storage array, to do some sort of patching. Right? Well, I can put that data store in maintenance mode. And what storage DRS will do is it will automatically evacuate that data store for me with no service interruption. So now I can go ahead and take that data store on the left down. I can reboot my fiber channel storage array, do whatever maintenance I need to do. And when it comes back, that storage load will be rebalanced according to storage DRS's recommendations. So it definitely helps with things like maintenance. And the first step is to create a data store cluster. Now, you have to bear in mind that virtual machines are going to be moving around from one data store to another. So you want data stores that are going to act similar. And that means data stores with similar performance characteristics and data stores with similar policies. Like, for example, if one data store is replicated, we don't want a virtual machine automatically moving off of it to a data store that is not replicated. We can't mix NFS and VMFS data stores in a cluster And we want to make sure that any shared storage within that cluster is available to as many hosts as possible. Now, when we're setting up a storage DRS cluster, it's very similar to a DRS cluster for our hosts in that we can choose the level of automation. Right? In manual mode, when I create a storage DRS cluster, it's not going to do anything automatically. What it's going to do is simply provide me recommendations. Say, this virtual machine should move from this data store to this data store. That's going to give me the option of whether or not I want to carry out those recommendations. In partially automated mode, when we create a new virtual machine, we'll create it on a cluster. Right? When we create a virtual disk, for example, we'll just pick the cluster. And in partially automated mode, storage DRS will pick the optimal data store for that virtual disk. Right? So in partially automated mode, we're kind of halfway there. Right? Storage DRS isn't going to automatically move anything anywhere, but when we're creating a new virtual machine, new virtual disk, storage DRS will decide where to put it. And then finally, we have fully automated mode, where our storage DRS cluster will automatically use storage vMotion to migrate virtual machines from one data store to another, again, for the purposes of load balancing capacity and latency. So in this lesson, we learned about some of the following topics. Right? We definitely gave you a very concise description of storage DRS. Again, I would recommend some of the more in-depth classes if you want to learn more. We've got the vSphere Foundations course coming out soon, and we'll also be releasing a vSphere professional level course as well on Udemy. So all of those courses will take you much deeper into some of these features. So anyways, in review, in this lesson, we learned about the following topics. We can have multiple data stores associated to create a data store cluster. And then we can monitor space usage and I/O latency across that data store cluster and carry out recommendations. Right? Very similar to DRS that we use with our hosts. We can carry out these recommendations and use storage vMotion to migrate virtual machines around. All right, we can always add more data stores to a data store cluster as we need to. And again, the underlying mechanism for these moves is storage vMotion.